I grew up on a farm in Saskatchewan. My closest neighbor was 3 miles away, and it was my grandparents. So when the lights were off in the house, it was dark. So when you look up at the sky, you see this beautiful blanket of stars just covering you. You could see, you know, the band of the Milky Way. It really was just this awe-inspiring view that you had every night. And so I knew when I went outside, being able to see this, I knew I wanted to work in space somehow. I had no idea how I was going to do it, but I knew that I wanted to be a part of it.
My mom has, you know, those books used to fill out every year what she wanted to be. It was like geologist, you know, like I didn't know how to spell it, but that's what I wanted to be. The most exciting fact about meteorites is they're all different. What I like about them is each tells a story about our solar system. What's exciting about Bennu is that it's a rock from outer space that we've never studied before.
This is an opportunity to literally go back in time by 4.5 billion years and understand what the early solar system was made of. So it's completely exciting for scientists on Earth. These are the materials that haven't changed in about 4.5 billion years. So it's literally like, it's a geological time capsule that allows us to go back through history. OSIRIS-REx is an international collaboration led by NASA that's going to an asteroid named Bennu, and it's going to bring a sample of that asteroid back to Earth. So Canada has contributed an instrument on board the spacecraft called the OSIRIS-REx laser altimeter, which is, you can think of it like a 3D scanner. It's a laser that's going to help measure the shape of the asteroid so that we can put the geology into context, and also so that we can select a sampling site safely. Ultimately, the heart of this mission is to be able to collect a sample and return it safely back to Earth. What's amazing about this is that this mission has been years and years in development. There's a 2-year cruise after launch just to get to the asteroid. We're going to then measure the asteroid with our instruments for approximately 2 years. And when we go in to collect a sample, we're going to contact it for a grand total of about 5 seconds. We have an arm that extends out that has pressurized gas in it. When that arm makes contact with the surface, it releases the pressurized gas. It puffs up a plume of material that we're going to then capture, close up the canister, and immediately back away and get the spacecraft into a safe place. The minimum amount of sample that we're hoping to get back on this mission is approximately 60 grams. Sometimes that doesn't sound like an awful lot, but when you think about entire careers can be made on the understanding of a single grain, 60 grams can keep an army of scientists busy for decades and decades.
Part of the mission is the sample return. That's what I'm most excited about, is the sample coming back to Canada that we get to work on, and that's my role.
Honestly, at the end of the day, like, we're firing lasers at asteroids, and if you can't get excited about that, then you can't get excited about space exploration. It's mind-boggling to think that we have the ability to go out and do this. That's why I show up to work every day.
Down to even the small little grains can tell us about how the solar system formed, and that's what gets me excited in the morning.
I'm Tim Haltigan from the Canadian Space Agency, and I'm the Canadian Mission Manager on the OSIRIS-REx mission.
My name is Dr. Kim Tate. I'm the Curator of Mineralogy here at the Royal Ontario Museum.